Okay, good evening, everyone. My name is Susan Knight. I work at the University of Wisconsin Trout Lake Station, and I want to thank you all for coming, and welcome to Science on Tap-Minocqua. Science on Tap is an example of the Wisconsin idea, an idea that was conceived in 1905, that the borders of the university are the borders of the state. We're set up here to be a discussion and not just to be a lecture, so hopefully you all came with great questions for our speaker tonight. I'd like to remind you about our partners in Science on Tap. You just heard from Frank Rossell, who's one of the heads of the Wisconsin Alumni Association Lakeland Badger Chapter. Another partner is Kemp Natural Resources Station, Trout Lake Station, where I'm from, the Minocqua Public Library, and of course our hosts here, the Minocqua Brewing Company. And another little reminder that there are 4 ways to watch this. Of course, you can watch right here like you are tonight. You can also watch live at the Minocqua Public Library, and now you can watch live at the Presque Isle Public Library. You can also live stream from your own home anytime. You can live stream it at home, and we have it. It's ad-free, and it's very easy to do. Just go onto our website and click Watch Science on Top Live. And then finally, you can watch archived shows. So our full hour and a half shows are available about a week or so after a week or two after they've actually been presented. And we're starting to work on short versions. These are 5 to 10 minute long versions, just sort of some little snippets of the entire program. And those will be coming soon. So our next event is on April 6th, 2016, and it will be National Parks with Janet Silbernagel, University of Wisconsin-Madison professor. So that should be great on National Parks. Tonight we are most honored to have The Wonderful World of Wisconsin Fishes with John Lyons. John is originally from New York State, where he went to college. He came to UW-Madison in 1979 to attend graduate school. He fell in love with Wisconsin and never left. He did both his master's and his PhD at Trout Lake Station. We were grad students together. So he knows the Vilas-Oneida County area very, very well. He's a fisheries research scientist with the Wisconsin DNR, and he is also associated with the UW-Madison Zoology Museum. John's worked all over the state on all kinds of issues dealing with all sorts of different fish in every type of water, from the Mississippi River to the Great Lakes and to all the little lakes in between. He's also worked a great deal on freshwater fish in Mexico. In fact, he said he just got back a few days ago and on his way again. John collaborated with Candace Elliott, a very talented artist, to create a really cool poster, we're going to see a little later, of all the fish in Wisconsin. Each fish is depicted as its actual average size, all the way from a real tiny one, all the way up to the sturgeon, which is 6 feet long. The whole poster is 13 feet long, so it may not be suitable for everybody's living room. We have one at Trout Lake Station, and it is spectacular. So I hope if you ever get a chance to come up to Trout Lake, just come in just to see the poster. It's very much worthwhile. John's long-term quest is to make as much information about all the fishes, and not just the game fish, of Wisconsin available and accessible to the public in a fun and easy-to-understand format. All right, so now a little John trivia. John became interested in fish because he loved to go fishing. One of John's favorite memories was when he, his dad, and John's son all went fishing together. His son was then 7 years old. They were fishing in the Hudson River in New York, John's home state, near his parents' house, I expect. And they were in a boat casting towards shore. They were near a fancy riverfront restaurant where a lot of very elegantly dressed people were eating dinner on a deck next to the river. There were some mallard ducks around, which wasn't uncommon and not usually an issue, but unbeknownst to John, the restaurant people fed the ducks so that they would hang around for the diners to be able to watch them. The ducks were conditioned so that as soon as something hit the water, they went after it. So John cast a little too close, and one of the ducks immediately scooped up the bait. The duck started thrashing around and trying to fly away, while John, mortified, tried to bring it in and get it unhooked before all the restaurant patrons noticed. He was working it closer to the boat, thought he could release it quietly, when his 7-year-old son, Eric, noticed what was happening. What did Eric say? A, quietly, almost under his breath, "Dad, did you catch a duck?" Or B, Eric announced in a quiet voice, "Dad, I think you caught a duck." Or C, did Eric say in that 7-year-old kind of a way, "Dad, you caught a duck! You caught a duck! You caught a duck!" Yeah, it was C. So, anyway, I will be monitoring Ustream for any texts coming in as questions. So, if anybody has any questions, we will monitor them. So, let me turn it over to our speaker, Dr. John Lyons. Thanks.
Well, thank you, and thank you, Susan. As Susan mentioned, I came here to grad school back in 1979, and I did truly fall in love with the state. And one of the things I absolutely fell in love with was the fish fauna here. And ever since then, since the early 80s when I was in school, I've really had a passion for all of the fish in the state. Certainly, I love walleyes and muskie and bass and trout and all the game fish, and I still love to fish. But I'm also interested in the little fish, the dicky fish, so to speak, and the lesser known, the bizarre fish, some of which are actually quite large. And so what I want to do today is just give you a taste of some of the variety out there. We'll talk just about the fish fauna a little bit in general, talk about what I consider the most bizarre fish in the state, and then talk very briefly about a fish that's really well known. Probably most of you are aware of, many of you have caught fishing the bluegill, and talk about some of the lesser-known aspects, particularly of the bluegill's love life, and some of the stranger things there. And I think you'll be kind of amazed that this well-known, popular fish actually has a really fascinating, kind of kinky almost, kind of spawning behavior. So let me start with a question of the group. How many different kinds of fish do you think occur in Wisconsin? What would the number be? Somebody give me a number. 47. 33. How much? 65. 285. Okay, so we're all over the board here. But you're not that far off. When I ask this question in some of the UW classes I sometimes teach, I get numbers like 10,000 or 4. And so the actual number, and there's a variety of ways of calculating this, but the number I go with is 165, okay? And that includes fish that were native here originally, as well as fish that have invaded or been introduced and become established. So, is 165 a big number? Is that a lot? Well, let's put it into some context. So, Wisconsin has 165 fish. It actually has more fish than the states of Washington, Oregon, California, Arizona, Nevada, and probably New Mexico combined. So we have a lot of fish species. We have more species of fish than the entire country of Germany, more species than England. So in terms of a temperate fish fauna, we have a very diverse fish fauna here. And that, again, that's one of the reasons I fell in love with it. There's this amazing variety. Now, if you go into a tropical context, if you were to go to Peru, for example, you would find about 800 species of fish. And if you were to go to the Great Barrier Reef, say, and again, these are marine fish as opposed to freshwater fish, you'd find about 1,200 species of fish in a roughly comparable sized area to Wisconsin. So for a temperate fauna, we have a really diverse fauna, but in terms of tropical faunas, where just biodiversity is higher, we're not so great. Now, that 165 encompasses all sorts of interesting creatures. Obviously, it includes the walleye, the muskie, the bluegill, all these species you're familiar with. But it also includes a lot of really unusual things and a lot of tiny things. So the smallest native species we have in the state is a species called the least darter, and that has a maximum length of about 1 inch and a maximum weight of about one gram, which is about a 35th of an ounce. Now that's as an adult. And then you can find least darters in the same water where you find the largest fish in the state, the lake sturgeon, which can approach 200 pounds and 6 feet in length and can live for over 100 years, whereas the least darter basically has a 1-year generation time, might live to age 2. So you have this amazing diversity, sometimes in the same body of water. And there are least darters in Vilas County, for example, and the Trout River has least darters. There are lake sturgeon in the Manitowish River, so they're right around here. So let's show you this poster and give you just a sense of what the entire fish fauna looks like. And you can get a sense of this. You want to just move that? And I should say that this poster, it's through the Zoological Museum in Madison, and you can actually purchase this. So if anybody's interested, I will be happy to talk to you about it later. So these fish, oops, get that out of here. Yeah, I'll do it. There, I got it. So this is all the fish in the state, all of them adult life size. So you have fish here, you can't even see them from the back, that are 1 inch long, and then of course you have the lake sturgeon. This is a little lake sturgeon, it's only about 5 feet long. And you have everything in between. So there really is an amazing fauna in the state, and again, this will be up here if you want to look at it later. So yeah. Now let me talk about the most what I consider the most bizarre species in the state, and that is actually the second biggest species in the state, the so-called paddlefish. Now the paddlefish is aptly named, and I'll show you a model of one in a second, because it has for a snout, it has a gigantic protuberance which can only be described as like a canoe paddle. And this fish can reach 100 pounds in weight, so it's the second biggest fish in the state. And while you don't find it here around Vilas County and Oneida County, you find it actually in the larger rivers of central United States. So in the Mississippi, the larger tributaries such as the Wisconsin, the Chippewa, the St. Croix. Historically, there were a few in the Great Lakes, although they've disappeared from there. And so I have this model here, but this is what a paddlefish looks like. So it truly has a paddle for a snout. And people have known about this Europeans, I should say, have known about this species for about 250 years. And in fact, among other people, Thomas Jefferson was particularly fascinated by this fish. He was fascinated by all things from what was then known as the West. He never himself actually got west of the Appalachians, but he collected all sorts of information and actually wrote a book about the Mississippi River, even though he had never been there, and talked at length about the paddlefish and what an interesting fish it was. And if you look at it, I've got it the wrong way. If you look at it, it's kind of a bizarre-looking creature. Early naturalists actually thought it was a type of shark, and it does. It has no scales, has this what's called a heterocercal tail, where the top lobe is longer than the bottom lobe, so which is shark-like. But then it had this weird paddle. And so people for years have been speculating, what is this paddle for? There's nothing else like it anywhere in North America, really anywhere in the world. And this particular individual, I mean, this is a relatively short paddle. Some fish have paddles that would go out to here. And so the early naturalists thought, well, maybe it's something they feed with, and they use it to kind of dig up the bottom and stir up the bottom to eat bottom things. Sounds plausible, but in fact, there's no evidence they do that. These fish kind of swim around in mid-water. They don't really go to the bottom much. There's no evidence they dig at the bottom with this. what they do is they swim around with their mouth open, filtering things out of the water. So even though it's a big fish, it eats tiny microscopic plankton in the water. And so people thought, well, maybe this is some sort of a hydrodynamic stabilizer. So when you open this big bucket-like mouth, and it will, and you have this jaw hanging down, and all this water pressure pulls the fish down, so this is some sort of counterbalance. And it kind of, that kind of makes sense at first glance, but when you do the calculations, A, you don't need it, and B, you can find paddlefish that have had their snout damaged and lost, and they can still feed just fine. So people were at a loss for a long, long time. But then recently, people started to realize that, in fact, what this is an electroreceptor organ. And when we think of electric fields, we typically think of, something around a transformer on a power pole, or the field that you get when you plug something into your outlet. So these very powerful electric fields. But in fact, every living organism produces a minute electric field. I'm producing an electric field, you're producing an electric field. The tiniest organisms produce electric fields as they move. And in fact, most of these fields are almost undetectable without the most sophisticated and sensitive sensory equipment. But it turns out that this snout is lined completely with very sensitive electroreceptor tissue, and that paddlefish can detect the electric field produced by a microscopic zooplankton swimming in the water. So, and this is in the order of picovolts, so billionths of a volt in electrical potential in that field, 1/1000th of a volt. And they can pick it up with this snout. And so it's a highly specialized electroreceptor organ. And interestingly, the other species that use that sort of electroreceptor, or some of the other species that use the electroreceptor, are in fact sharks. So even though this isn't a type of shark, it's not even remotely related, it uses some of the same feeding behaviors and actually is able to feed in very dark, turbid water and detect these minute electric fields from things that are less than a millimeter in length and use them for feeding. So this wins to me for the most bizarre and certainly the most interesting looking fish in the state, but there are lots of other candidates. Now, last but not least, we'll turn our attention to a much more common species, and that is the bluegill. And so probably all of you have seen a bluegill. Many of you caught them and ate them. They're delicious to eat. They're wonderful to fish for. They're extremely common. They're found all over the state. There's lots of them out here in Minocqua Lake. Most of the lakes in Vilas County have lots of bluegills in Oneida County. And this picture is of a spawning male bluegill. And most people who fish know that in the spring, bluegills make beds of nests in shallow areas of lakes. People call them the beds. And a whole series of bluegill will make these little nests, and the males will defend them. And then the females will come in and spawn, and then the males will defend the eggs and defend the fry after they hatch. And that's certainly part of bluegill spawning behavior. That's the well-known part, the part that anglers know about and take advantage of, because the males, when they're on these beds, are very aggressive and very easy to catch, very conspicuous. But as people have studied this species, they found that it's far more complicated than that. In fact, there are two other types of male, what you might call types of male bluegills. This big one that kind of defends the nest we call the parental male. It's the parent. It guards the eggs, it guards the young, it guards the nests. It's the father figure for the young bluegills. But there are two other forms of bluegill males out there. The first kind are the kind that are called the sneaker bluegills, the sneaker males. And they look just like this, and this is a juvenile bluegill. So a big male bluegill might be 7, 8, 9 inches long. A juvenile bluegill might be 2 or 3 inches long. And at first glance, you say, well, that's just a little bluegill. But in fact, some males actually mature when they're 2 or 3 inches long and retain all of the juvenile characteristics. So they look just like a juvenile. And the only way you could actually tell one apart would be to actually dissect it and look at the reproductive tissue inside to determine whether it was a true juvenile or a sneaker male. And what the sneakers do is they hang around the edge of these nests, And they wait until the male is in the midst of spawning with a female, and then sneak in and sort of slip in right under when they think no one's looking. They fertilize a few eggs and then get out of there because the big parental male is pissed at this point because he knows what's happened. But this actually turns out in many situations to be a very successful strategy. Those big males, when they're on the bed, they're doing a lot of work. They're guarding this nest, they're guarding the young, they're obviously vulnerable to anglers and other predators because they're conspicuous in the shallow water. And so this is kind of an alternative way to get the same thing done. You don't invest a lot of your energy into growing big and strong and fighting off the other males. You just pretend you're a kid and hang around and then sneak in when you get the chance. Now, of course, it's also dangerous because then the male is mad and he's chasing you, and you're a little bluegill. So a lot more predators can eat you. And so it has its own sort of precarious nature. But then there's a third form, and this one is called a satellite form. And this form looks like this, and so it looks identical to a female. So this is what a female bluegill looks like. It doesn't have the yellowish or orangish breast area. It's not as big, not as darkly marked. But in this case, basically what the male does is it essentially imitates a female. And it gets a little bit bigger than those sneaker males, which might be 4 inches long. Now this is about 5 or 6. Looks just like a female. The big parental male's in there guarding the nest. It has one true female come in, and then right behind it is what this male thinks is a second female. So hey, it's my lucky day, I've got 2. But in fact, it's another male. And so it behaves like a female, it looks like a female, and then as the male begins to spawn with the true female, it all of a sudden then ejects some milk and tries to fertilize some eggs that way. So it's basically a transgender fish in a way almost. And so when you're out there, the next time you're out there fishing and you're on the bluegill beds and you're catching fish and you're looking, and it really is fascinating to sit on the bank or from a boat and watch the dynamics of these beds in clear water. Bear in mind that there's all kinds of crazy stuff going on down there. It's not just the straightforward, here's a male, here's a female, they lay some eggs, the male guards it, and that's that. But in fact, there's all these dynamics, and there's all sorts of interesting, scientists can look at the trade-offs of sort of, depending on the type of lake you're in, the type of situation, sort of which way should you go as a male? What's sort of the most effective way to actually be able to actually fertilize some eggs and pass your genes on to the next generation? So anyway, that's something bizarre about a well-known fish. Then we have the bizarre fish like the paddlefish, which is bizarre in its own right. And they're just 2 of 165 species we have. And there are lots of other interesting stories. So I'll be happy to answer questions about any and all fishy stuff.
Can you tell us something about fish that might have occurred in the Wisconsin River in Oneida and Vilas counties 200 years ago before there were dams? Did flathead, catfish, paddlefish, sturgeon, gar, and American eels swim all the way up by Lac Vieux des Airs?
Good question. The answer to that is probably not quite that far up the river. Things like the paddlefish, the lake sturgeon, the flathead catfish are really big river species. They need a lot of habitat, a lot of deep water, open water. And so when you get up by Lac Vieux des Airs, the Wisconsin River is a stream, essentially. You can wade across it, throw a rock across it. So even when there weren't dams as barriers, they probably didn't get that far up in that system just because the habitat wasn't right. And even before there were dams, there were actually a number of natural barriers, rapids and falls on the Wisconsin River, the most prominent of which was Big Bull Falls in Wausau. And so that seems to be the upper limit, about the Wausau area, of where a lot of these big kind of Mississippi River fishes, that's about as far north or upstream as they would get. And even at that point, the river is getting kind of small for some of these. But that would have been probably as far as a lot of these true big river species got, Wausau area.
This regards the sturgeon. I've heard they go back as far as the dinosaur. And is there a concern with the spearing of the sturgeon that's going to affect the population?
Actually, the dinosaurs go back way before or the sturgeon go back way before the dinosaurs. So the dinosaurs evolved 70 million years ago in that kind of order, and the sturgeon go back at least 100 million years. So they're a very primitive group. Not as primitive as, there are some fish, the lampreys and hagfish, that go back about 300 million years and are literally the first vertebrates. But sturgeon predate the dinosaurs. Now, obviously, they've changed a little since then, but they have roughly the same body plan and so forth. The spearing that you're referring to, if you're talking about the Lake Winnebago spearing, that is certainly the most carefully regulated and monitored fishery we have of any sort in the whole state. So, in fact, that fishery is run in a way that it doesn't threaten the population at all. And in fact, in recent years, the population, both in terms of numbers and in terms of average size of the fish, has been growing because it is actually protected better than it was when the spearing first started, say, 60, 70 years ago. So that has no threat for the sturgeon population.
Regarding the bluegill, do these alternate males only produce those types of males, or do they produce a normal male?
Very good question. There is a genetic component, so if you are a sneaker male, your offspring are more likely to be a sneaker male, and same if you're a satellite, fake female. So there is a genetic component, but it's not hardwired. And in fact, for instance, if you had a situation where somehow or other all the big parental males disappeared from a lake, some of those sneaker and satellite males would in turn then develop into the normal parental type. So there's some flexibility there. There is a tendency to stay the same way, but it's not fixed.
Hello. My question is, we know that there's Asian carp in the Illinois River, and I'm just wondering if they could probably backwater down to the Mississippi and by extension into the Wisconsin River. Is that a possibility that could happen?
Yeah, it's a very real possibility, and in fact, there have been a few Asian carp, and we're talking on the order of tens, caught in the Mississippi River and in the lower Wisconsin River that we believe have swum up through the dams up from further down in the Mississippi and the Illinois River, up into the lower Wisconsin, into the Mississippi River, even and into the lower St. Croix River. The good news is, even though we see 1 or 2 or 3 every year, they're all big adults, and we have no evidence yet of any kind of successful reproduction or any establishment of a population. So it's something we monitor for and we look at and we spend a lot of time worrying about. But to date, and we're talking now almost 20 years, while we've seen occasional adults, we haven't seen any reproduction, we haven't seen any evidence that there's a population, and we think these are just strays that have, individuals that have swum up from further downstream.
My question is about global warming and its impact on the fish populations. How will that have an impact, and what type of impact will be?
Yeah, absolutely. We've looked at if the world gets warmer, and depending on how warm it gets, what the effects might be on different species of fish. And basically, we group fish into 3 categories for general purpose. We have cold water fishes, and that's the trout and the salmon and the whitefish, Cisco, a couple other things. They need cold summer temperatures. Then we have cool water species, which kind of like intermediate temperatures. That'd be things like perch, northerns, walleye would fall into that group. And then finally the warm water group, and they like the warmest temperatures, and that'd be bass, that'd be bluegill, a number of the other sunfish species, a lot of the minnows and some of the suckers. In a nutshell, if you're a cold water fish, of course it's going to get warmer, your habitat is going to shrink, and there'll be less habitat for cold water fish. If you're a warm water species, your habitat is going to expand, and you will likely have more habitat and increase. And then for the cool water species, it kind of depends on the specific lake and the specific species, and that's a little bit more complex, because in some cases it's going to get a little warmer, which would be beneficial. In other cases, being a little warmer is going to push them over the edge, and it will be marginal. So cold goes down, warm goes up, and the cool species kind of have a mixed response depending on where you are and exactly how warm it gets.
I have, just hang on a second, Carol. Two things. First of all, I forgot to get this poor man a beer, so. What did you want? He's dying of thirst. What was it again? Cream ale, please. If we could get a cream ale up here, lickety split, that would be great.
Hurry,
Okay.
hurry.
Very sorry. All right, second thing. We have a message came in on the internet. It says, John Lyons is my idol. Ah. Okay. Carry on, Carol.
I get that a lot. You know.
Going back to the bluegill situation, are you familiar with the hybrids, and could you tell me a little bit more about them?
Yeah. All of the sunfish species, including the bluegill, hybridize naturally. So that means one species, the female of one species and the male of another species, mate and produce offspring. And it's actually pretty common among the sunfish species. It's also common, you see it in some of the trout, you see it in some of the minnows, you see it in some of the sucker species. So it happens fairly often with a variety of different species, but it's particularly common in the sunfish. And bluegills hybridize sometimes with pumpkin seed sunfish, they hybridize with green sunfish, a number of other things, a warmouth sunfish. And so it happens. And in this case, none of the other species really have, like a pumpkin seed doesn't have sneaker and satellites the way a bluegill does. So we think that most of the hybrids are just produced with a big parental of one species, because all of the sunfish guard a nest and have a big parental male, with just mating with a female. And it's sort of, people wonder if it's a question of, they just made a mistake, or sometimes if one particular population of one species in a lake is really low and the population of another is high, there's this thought that maybe the species that's really low, the females just can't find a male of their own species, so it's sort of a love the one you're with scenario where they go to they just go to, there's all these other males of the other species and they end up mating with one of them. But it's pretty common in sunfish, and you see it a lot.
Hey, John.
Hey, John.
165 species. Can you tell us, looking at small streams, what is the most diverse type of small stream, and explain what that small stream would be, what type of system?
Okay. Well, I had mentioned on the climate change question that we classify species as cold, cool, and warm. And basically, there are a lot more warm species than there are cold species. And so the places that have the most species are these little warm water systems. They're too warm for trout, and so oftentimes as anglers and as people, we don't maybe value them as much because they don't have trout, which is, of course, a very valuable fishing species. But often these little tiny roadside streams that don't look like much and people don't give much thought to because they can't really fish there are just tremendous reservoirs of diversity. And it'll have 15, 20, 25, even in some cases under ideal conditions, 30 different species. Now, to put that into context, Lake Minocqua here has about 20 species in it. So these little streams, the kind of thing you drive over in your car and you don't even notice, may have more species of fish, again, small non-game species, than all of Lake Minocqua. And so these are very valuable resources, and a lot of people don't appreciate just how important they are to maintaining biodiversity and maintaining sort of the health of our aquatic systems. And for example, just as if you're familiar with the Trout Lake Station, there's a little creek that runs right by it called Man Creek on County N, and that has about 25 different species in it right there at the road.
John, Man Lake here in Vilas County has a history of winter kill. Over the past several weeks, we've been monitoring the dissolved oxygen level at 1.4 milligrams per liter. I have a two-part question involving dissolved oxygen. First of all, are species other than carp or bullheads able to adapt to such low dissolved oxygen levels and survive in the lake? And secondly, is there studies or evidence to indicate that aeration systems can be effective in a situation or a lake like this?
Okay, related to the first question, yes, when you get down about 1.4, there are very few species that can tolerate oxygen that low. The champion species in terms of low oxygen is a really common species up in this part of the world called the mud minnow. And maybe you've seen it for sale as walleye bait around. It's a good walleye bait. It's a small brownish species, and it can tolerate almost down to no oxygen whatsoever. And my advisor actually did studies on it that showed that when you're in a winter kill lake like that and the oxygen's really low, the mud minnows will actually go up under the ice and find little air bubbles under the ice, and they have a air bladder where they can take air from the surface and bring it into their air bladder almost like a lung. And so they can breathe these little tiny air bubbles. And then they are able to survive better than basically any other species. Bullheads are pretty good. Northerns are surprisingly good at maybe not 1.4, but they can get down around 2. And there's a number of other minnow species and a number of other species. But certainly things like walleye, a lot of the bass, that's going to be too low for them. Now, in terms of aeration, yeah, if you can keep an area of the lake open so it isn't ice covered, then that allows oxygen mixing into the water. So that, at least where the aerator is, there'll be sufficient oxygen. Now, again, if you're in a giant lake and you're keeping open a hole 10 feet wide with an aerator, it's only going to be able to protect a relatively small part of the lake and a relatively small part of the population. But aeration can work, and particularly in a smaller lake where you can keep enough area open, but it does oxygenate the water. Now, in something like Man Lake, that's a big lake, or a reasonably big lake, so you would ideally have more than one system, I think, if you really wanted to keep a big chunk of the population protected, because again, the area that gets oxygenated is relatively small, right around the aerator, and it doesn't extend 50 or 100 yards away. It's just local where you're able to keep the surface, keep the ice off the surface. So it's a pretty localized effect, but in that localized area it works.
Okay, I'm going to jump in for a second. Just a quick comment that we have 20 people online tonight, including students from UW Green Bay. About 20, yeah, so that's great. Okay, so we have another question. What is the reason that muskie have so many different scale patterns? Some are solid, some are striped.
Yeah, people have speculated that there are a lot of differences in muskie appearance. And the early scientists, the early ichthyologists described a whole bunch of different muskie species based on those different patterns. And they gave them all different names. And even today, some people talk about different subspecies of muskies. It turns out when you do genetic analyses and you really look at it in detail, a lot of these quote-unquote species, a lot of these different populations aren't really genetically distinct. And I think, I can't say for certain why there's so much variation, but I just think that a muskie pattern is a camouflage pattern. It's going to blend into its background because a muskie is an ambush predator. It wants to sit somewhere, be kind of invisible until its prey goes by, and then zoom out and grab it. And so I think a lot of the pattern variability is just this idea that there are loads of different camo patterns out there, and if everything looked the same, then, if every muskie looked identical, then I think eventually their prey would kind of evolve a recognition sort of sense where they would be able to say, well, that's a muskie. That pattern indicates a muskie, where if each muskie looks a little different, then their prey isn't really going to be able to, hone in on that one pattern. And, and there may be some genetic component to that, and there may be some component based on how dark the water is and things like that, which sort of camo patterns you're more likely to see. But I think a lot of it is just individual variation. Just like we all look different in this room, individual muskies look different.
I'm curious about just the integrity of the food web, all the way from the little guys up to the big guys, and with all the environmental pressures over the years, just how that, the series of fish, the bigger fish eat the littler fish, et cetera, all the way up the food web?
Yeah, that is the nature of things. Even though most of us are most interested in the game fish, which tend to be the top predators, the top of the food chain, you can't have a good fishery, a good walleye fishery, for example, or a good muskie fishery or bass fishery, unless you have that supporting base of the food web. And as a rough rule of thumb, for every pound of walleye, for example, you're going to need about 5 to 10 pounds of food to support that. So if you figure each individual minnow might weigh 1/100th or a 500th of a pound, then that means for each walleye you're going to need 10,000 minnows or something on that order. So that's critical. So a lot of these smaller non-game fish, the stuff I've been talking about I love so much, it isn't just sort of an academic interest. It is critical that these non-game species have healthy habitat and healthy populations in order for the larger top predators, the things we fish for, to survive as well. So something that knocks down the abundance or the health of those smaller non-game fish can then go up the food chain and affect the game fish at the top as well.
So my question was just about the health of all those steps, just with environmental pressures. Has that changed any over the last 50 years? Are parts of that food web vulnerable?
Yeah, absolutely. And it depends on where you are and what system, because there are parts of the state that have gotten a lot better in the last 50 years, particularly our bigger rivers, which had been the dumping grounds for a lot of our wastes. In some of our lakes, then, some of the habitat has degraded in the last 50 years, and so there's some real questions about the viability of some of what we'd call the forage base or the prey base and some of the habitat for them. But it really is and that is one thing we spend a lot of time in the DNR monitoring and assessing is not just the health of the game fish at the top, but the health of the entire fish community, the entire ecosystem. And there are certainly places where it's gotten better and places where it's gotten worse in the last 50 years.
So I have a question from the library that I just lost. Is the satellite bluegill and the juvenile bluegill the same species or a subspecies?
They're all the same species. So it's basically one is an immature and one is a mature male that looks like an immature. So basically, instead of at one point, all the bluegills were juveniles. And some of them grew up to be these big parental males and look very different. And some of them basically stopped growing in length and size and matured at a very small size. And so they might be a couple years older than a true juvenile, and they are, but they're the same species. They're fertilizing, the same eggs from the same female, and they produce bluegill offspring.
Question here? Okay. So piggybacking on the trophic related question, can you speak to the PCBs or metals in fish tissues of fish, top predators or others?
Yeah, so you're talking about the contaminants. For instance, they have advisories about eating and things. What happens with a lot of contaminants, particularly PCBs and as well as mercury, is a small amount, there might be a small amount in the environment, and that gets into some of the aquatic insects in a small amount. And then those aquatic insects are eaten by a little minnow. And with things like PCBs and with things like mercury, which are the two things of concern, each time it moves up the food chain, it kind of gets concentrated. So this little minnow, there's 10 bugs out there, each with a tiny amount of mercury, for example, or PCBs. And then this minnow comes along and eats those 10 bugs. Well, now it has 10 times as much as each individual. And then that walleye comes along and eats 10 minnows, and so it has 10 times as much as the minnows do. And it's what's called biomagnification. And so even though there might not be a lot of, if you look at the absolute concentration of PCBs in the water or the sediment, it might not be that high. It gets concentrated by the food web so that it ends up in those top predators. Now, And then we, being the predator on the muskie, or being the predator, I guess, on the walleye, most people don't eat muskie anymore, but people who eat walleye, we concentrate it ourselves. So we eat 10 walleyes, and we get 10 times as much PCBs as each walleye has. And things like PCBs and mercury, they accumulate. They aren't excreted. They aren't pushed out of your system very fast at all. So maybe years later, some of it will dissipate, but most of it just sits there, mainly in your fatty tissues. And then the PCBs when it gets to a high enough concentration, then it can cause health issues. Typically, it doesn't get high enough in the fish to cause health issues for the fish, but it does for people, because again, we get maybe 10 times more than is in the fish. And so that's why they have the health advisories and tell you don't eat so much, only one meal a month and things like that, just so that you don't concentrate it in your own body and suffer health effects.
I'm on one of these small deep water lakes that are common up in northwestern Vilas County, and 36 acres, 60 feet deep. Is it common for lakes like that to have a double fishery, a warm water and a cold water?
Yeah, what we'd call a two-story fishery, where during the summer at least, up in the surface water, you have warm water fish like bass and bluegill, and then in the lower depths, where it remains cold because the lake stratifies, which is a whole other discussion, but that remains cold down there, and often there will be cold-loving fish, particularly something like a cisco, which is a type of whitefish, that will live in the bottom. 35 acres is pretty small. We know of a few cases where you'd have a two-story situation there, but certainly when you get up around, there are lots of two-story lakes in Vilas County. 35 acres would definitely be on the small side, but when you get up about 100 acres or so, then they're fairly common. There's 100 or so lakes like that in the greater Vilas, Oneida County area. So that sort of two-story fishery is somewhat unique statewide. There's only maybe 200 lakes that have those characteristics in the state, and about half of them are in this area. And all the way up to the big, Turtle Flambeau Flowage has a two-story fishery. Lake Minocqua and Kawagasauga has a two-story fishery. Tomahawk Lake. Big deep lakes are where they do best, but you can get small deep lakes too where you have some.
Are you concerned about the effect these mega farms are having on our trout streams?
There's certainly the potential for issues because of the vast amounts of manure that are generated. And so the issue is how that manure is managed. And if they have the appropriate storage facilities, and if they are going to spread it, they spread it at the right times. It can be done, without impact. But if it's not done correctly, if there isn't sufficient capacity, or if it's spread, say, on frozen ground and then it rains and things like that, then there are certainly, every year there are instances where there's runoff. And not necessarily just from the mega farms. It happens from small farms as well. It's a question of how much manure you produce and how much storage capacity you have to hold it, and how much, how many fields, acres of fields you have to spread it at the appropriate time of. And typically by late in the winter, a lot of the storage facilities get full, and that's when the trouble arises. So it's true of any farm that has livestock, but of course, the bigger the farm, the bigger the volumes.
Question online?
I do want to point out that I did get you.
Oh, thank you.
Okay. Yes, we have a question kind of centered here on Minocqua. Could you spend a few minutes discussing the value of bowfin or dogfish to a lake system? People on the Minocqua chain catch and kill them because they think they're destructive.
Yeah, the bowfin is a native fish, a native predator. It's one of those ancient fish that dates back almost 100 million years or so. Very little change from that time period. And it's called the dogfish, it's called a mudfish, it has a variety of names. And it lives in the shallow, kind of weedy areas, and you can catch it fishing. People catch it. You're casting a bait for a bass, you might catch a bowfin. Historically, to be honest, and this is the fault of fisheries biologists such as myself, or at least my predecessors, historically we looked at things too simplistically and we said, well, bowfins are competing with the walleyes or competing with the pike or something like that. So if we had fewer bowfin, there might be more walleyes. But of course the world isn't that simple, and in fact bowfin have their own specialized niche. And so they are really well adapted to kind of marshy, almost stagnant areas and areas where you really don't find many walleyes. And so they're adapted to being in these areas. And in fact, not that we have a problem with carp here in Minocqua Lake, but in places where there are a lot of carp, for example, it's been found that bowfin are a very good predator on juvenile carp. And so we fisheries biologists in the last 30 years or so have really changed our tune on bowfin. There's a similar species called gar, which is another native predator, that they don't actually compete with a lot of our preferred game fish. They actually complement them. They occupy a different habitat. They eat different things. And in some cases, they eat things we want to be rid of. They control things that might be a nuisance, such as carp, or at least reduce them a little bit. And so as fisheries biologists, we actually encourage these fish, and we want people to release them if they're not, unless they want to eat them or something. We want them to be released. Killing them does not help the rest of the fishery, and in fact, there are situations where it might actually be harmful to the rest of the fishery. So bowfin, gar, some of the other native predators, these ancient fish that have adapted for specialized habitats, they're just part of the diversity we have, and we should cherish that rather than try to get rid of it.
Here in Vilas and Oneida County, are there threatened and indicator species that are being monitored similar to the long-eared sunfish in the Mukwonago River in southeast Wisconsin?
Yeah, in fact, there are long-eared sunfish here in Vilas County. There are long-eared sunfish in the Trout River and probably a few down in the Manitowish chain of lakes. So that is it's actually a state-threatened species, and there's actually a very nice population in the Trout River between Trout Lake and the Manitowish chain. There are several other threatened, and I don't know if there's any endangered species here in Vilas and Oneida. There is a species called the pug-nosed shiner, which is a rare species. There's a number of others. By and large, the majority of our rare fish are in our bigger rivers. And so you get down in the Mississippi and the lower Wisconsin, that's where a lot of the rare species are. But there's at least 2 or 3 rare fishes here in Vilas, Oneida, and the long-eared sunfish is actually up here, just like in the Mukwonago, which is in for people that don't know, that's a river in southeastern Wisconsin, Waukesha County, which is a stronghold for endangered species.
Do you have a question?
Another question from the library. Were there ever grayling in Wisconsin, and what is the purpose of the sail fin on a grayling?
As far as we know, there were never native grayling in Wisconsin. Grayling is a type, it's in the trout and salmon family. It's a fish that really likes cold water, and it's particularly sensitive to pollution and habitat loss. And historically, most of the grayling in North America are up in northern Canada and Alaska, and there are some out in the northern Rockies. And then there was this little pocket of grayling in northern lower peninsula of Michigan and the eastern upper peninsula of Michigan. And that's if there's a town in Michigan called Grayling, and it's named after the fish. Those fish, as far as we can tell, they never got into Wisconsin. So the nearest they were would be the eastern part of the upper peninsula, so over near Sault Ste. Marie and that area. There have been some attempts to introduce grayling in Wisconsin over the years. They've never gone anywhere. The grayling in Michigan they're very sensitive to habitat loss and pollution. And the last grayling disappeared from Michigan, I think, by about 1930. So they've been gone almost 85 years or so. And there have been a number of attempts to reintroduce them in Michigan without any success. Again, because they need the most pristine conditions, and most of those conditions aren't there anymore. There's still some in the northern Rockies, and there's lots if you get up into Alaska and northern Canada. Now, as far as the sailfin, that's a good question. I'm not an expert on grayling, but sometimes when you have these long fins like this, they don't necessarily have a sort of a hydrodynamic function to help the fish swim better or anything like that. But in fact, they're kind of an adornment to help the fish attract the opposite sex. And so these large, prominent sail fins on a grayling, which are much better developed on the males than on the females. I would speculate, and I don't pretend to be an expert on this, that at least part of their function is kind of a display. The way a peacock's tail is a display, the male peacock does this to attract the female, and I think there's an element of that in the grayling as well. They are a spectacular fish, but none in the Midwest at this point.
John, we have a question back here.
Yeah.
So I'm interested in, like, what is the daily life of a fish? You can pick whatever fish you have. How much do they eat, like a day, or do they not eat every day, or do they sleep? Do they spend time together? What?
Yeah, that's a great question. There isn't one single answer because each species is a little bit different. There are certainly some fish that are pretty much solitary. For instance, a muskie, unless it's actually in the process of reproducing, muskies are, they have their own territory and they're there themselves. There are lots of other species that are schooling species that are always found in a group. Fish feeding is driven by temperature. Basically, the warmer it is, the more they eat. So in the middle of the winter right now, when the temperatures are low, some fish aren't feeding at all. Some fish are almost quiescent, almost in kind of a quasi-hibernation. Other fish are feeding, but at a much, much lower level than they would during the summer when the temperatures are warm. During the summer, sort of at peak feeding time, I suppose something, if a muskie ate a really big fish, it might not feed for a couple of days. But most fish are trying to feed every day. And so they're eating constantly. They will eat as much as they can eat. And so most fish are feeding every day. Now, that doesn't mean they're feeding continuously. Some fish are nocturnal and feed mainly at night. Some fish are what's called diurnal. They feed mainly during the day. And then a lot of fish are what are called crepuscular. They feed at dawn and dusk. And a lot of it has to do with how vulnerable they are, how easy it is to sneak up on their prey or have a predator sneak up on them. And so the daily life, exactly when they feed and where they feed, really depends on the species. Do they sleep? Yes, most species of fish sleep. In some cases, they go to the bottom and don't move and actually kind of look asleep. In other cases, some fish are kind of swimming more or less constantly, and they're actually kind of on automatic pilot and sleeping while they're swimming. And swimming speed again is dependent on temperature. So the cooler it is, the lower their metabolism is. So they swim slower in the winter than they do in the summer and things like that. But it really varies. There's no simple answer. But yes, they sleep. Some are together, some aren't. They feed a lot, and temperature is the big driver. They're all cold-blooded, so the warmer it is, the more of everything they do.
Question back here?
Two questions about paddlefish. Do Asian carp compete with paddlefish? And the second is there any efforts to reintroduce paddlefish to the Great Lakes like the lake sturgeon?
So as to the first question, there is a lot of concern that Asian carp will compete with paddlefish because paddlefish, as I indicated, they open their mouth and just filter the water and eat these minute zooplankton organisms, these things you can barely see. And so when they're that small, they have to eat huge volumes of these and cover a lot of water. Asian carp do more or less the same thing. So when Asian carp get really abundant, they're competing for the same zooplankton prey resource that the paddlefish is. So there's definitely concern that Asian carp are competing with paddlefish. And most of the areas where Asian carp have become really abundant don't have a lot of paddlefish for other reasons. They already have some environmental problems that have knocked the paddlefish down. And so there isn't a lot of hard data whether or not paddlefish have been directly impacted, but there's certainly concern that as Asian carp move into areas where paddlefish are more common, that'll be an issue. And then the other question was? Oh, the Great Lakes, introducing paddlefish into the Great Lakes. No, at this point there hasn't been. Paddlefish were never common in the Great Lakes. In fact, for a while there was some dispute about whether they were really there, but there's been enough, because there isn't an actual specimen or a photo, but there's been enough sort of anecdotal evidence that people think there probably were a few paddlefish out there. However, the Great Lakes are kind of cold for paddlefish. It's not really ideal habitat for them. It was probably, even before the Great Lakes were modified by European settlement, it was probably always kind of marginal habitat. And so I won't say it's never going to happen, but I think it's a much lower priority than, say, sturgeon, which once upon a time were extremely abundant in the Great Lakes. And so you're trying there to restore, and the habitat for sturgeon is much better in the Great Lakes than it is for paddlefish. So there's no plans at the moment to reintroduce them. Okay. Hey, Lawrence.
I have another one.
All right, there we go. In your bio, it mentioned that you've done quite a bit of research in Mexico. Can you just brief us a little bit about that experience and your interest down there?
Yeah. First of all, let me assure you that I do work in Mexico in my spare time. The DNR doesn't pay for me to go to Mexico. I wish they would, but they don't. I take vacation and do that. And that was one of these chance things when I was in grad school. I had a good friend who ended up getting a job in Mexico, and he needed some fish work down there. And even though I knew nothing about Mexican fish, I was the only person he knew who knew anything about fish. So he brought me down there, and I did some work, and I really enjoyed it. And so over the years, through him and through other people I met, I've been going back there. And so I've been going to Mexico about 30 years now, and working. And as Susan, I think, mentioned, I was just there last week to work on a project. So I have a variety of projects. Most of them have to do with conservation-type issues. Mexico has a lot less water than we do here in Wisconsin, so there's always a conflict between other water uses and water uses for fish. It also has tremendous problems with pollution, and it has tremendous problems with non-native species. Exotic species from different places competing with the native fauna. So I've been doing a lot of different projects in different parts of the country on, basically working with Mexican scientists, Mexican biologists and conservationists on just, trying to figure out how to protect and conserve some of these species, many of which are highly endangered, and just deal with a lot of the pollution and scarcity of water kind of issues. And so it's definitely makes me appreciate what we have here in Wisconsin in terms of our water resources, and we're lucky to have the amount of water and the quality of water that we do. And not to say there aren't some very wonderful places in Mexico, but and I really like working there, but they have a lot of really serious environmental challenges, and I just try to help as I can.
If you see a sign posted on a smaller lake that's heavily stocked with bluegill and smallmouth bass that says no live bait, do you know why that might be, or is there any? I'm just curious if there's any more information. I've thought about calling the DNR and asking about things like that. Well, I'm just curious why that might be.
There are two reasons why live bait wouldn't be allowed. And for instance, there are some trout streams where we don't allow live bait, but that's primarily because we want people to release the fish alive, and when you use live bait, a lot of times you can't really effectively release them. That's usually not the case in a lake. We typically don't have an artificial-only fishing in a lake the way we might in a trout stream. And so I've not actually seen a sign like that, but I would suspect that if it's, say, put up by the local lake association, they're worried about fish accidentally getting in the lake mixed in with the live bait. So that is a way in which a lot of non-native species get spread around. People have them in their bait bucket, sometimes not even realizing what they've got, and they fall off the hook, or they jump into the water, and it's a way in which non-native species can get into the system and potentially cause some problems. So typically in a lake system, if there was a no live bait rule, I would suspect it's just so that these other species don't accidentally get introduced via a bait bucket.
There's a game fish stocking program will be started here in the area. What studies have been done about that in the past as far as the success of the fingerlings that actually make it to maturity and become not trophy size but edible size?
Well, the DNR does a lot of stocking, and then a lot of private individuals, lake associations and private individuals also do stocking. The success of the stocking kind of depends on the lake. There's certainly a lot of times people say, I want to have walleye in this lake, and it really isn't a lake suitable for walleye, so you can stock all the walleye you want in there, and they're really not going to do very well. I think what you're referring to is this new walleye initiative that is to stock particular lakes to really bring back the walleye, and that, in the DNR, we spend a lot of time making sure that we're stocking the right lakes, where lakes are actually appropriate, where walleye could survive and thrive, hopefully. And we're also stocking much larger walleyes than we typically would, what we call extended growth or large fingerling walleyes. Traditionally, the walleyes that get stocked are either the fry right after they're hatched, when they're about so big, or then what we call small fingerlings, which are maybe 2-3 inches long. And while there are certainly cases where those stockings have been effective, the majority of cases those don't work very well. Most of those fish that are stocked just become food for something else. But there's some suggestion that if you wait and raise these fish up to around 8-9 inches, that they've outgrown a lot of the things that can eat them, and they're going to survive a lot better. There's still no guarantee that they will, and a lot of them are going to die regardless. I mean, that's the nature of fish. Most of them die before reaching maturity. But the idea is that stocking these bigger fingerlings, these extended growth or large fingerlings, in the appropriate places, in the appropriate ways, the appropriate densities, and really focusing on doing it well, can jumpstart some of these fisheries where the walleye populations have declined. So that's a big initiative right now. We're spending a lot of effort, and there's a lot of lakes in Vilas and Oneida County that are getting these extended growth fingerlings. And the program's only been in place a couple of years, so it's a little too early to say how well it's going to work, but we'll be monitoring that to see how well it does work.
A quick follow-up to the poster. How can folks order the poster?
I have a web address here on this little poster, which is a cumbersome thing to read, but I'll leave this up here if people want to look, and you can maybe text it to this person.
Okay.
But essentially, you go to the University of Wisconsin Zoological Museum. They have a website. If you Google it, you'll get it, and then navigate. There's a page about posters, and there are various fish posters. There's also posters of bats. There's posters coming now on reptiles and amphibians. There's going to be one on freshwater mussels. Candace has done some really, really nice botanical posters of various types of plants that would also be available there. So she's a really, really good artist and loves to do this and is just doing it gratis. And so you go to that website and you can find out how to order.
Thanks.
Let's see. Back in the 60s, Lake Michigan was a terrific jumbo perch fishery. And then afterwards, the coho salmon was introduced, and then the alewife die-off started, and after that, no more perch. What happened?
Well, you've got the sequence not quite right. What happened was that the alewife really took off, had the die-offs, and then the coho salmon and the Chinook salmon were introduced to try to control the alewife that had become overly abundant. And that happened, you're correct, that happened in the 60s. Perch fisheries remained pretty good up until the 90s, in fact. There was some pretty good perch fishing in both Green Bay and around the Milwaukee area into the 90s. And so most of the decline in perch has happened in the last 20 to 25 years, the real major declines. Why that's happened is an area a lot of people are interested in figuring out, but most people suspect It has something to do with the invasion of zebra mussels, and then they were followed by a similar species called the quagga mussel. And essentially, these are a small species of clam or mussel that's native to actually Europe, and they came over probably on an ocean-going ship, and they've just exploded and taken over the bottom of the lake. And they've really changed the food web, where before a lot of the productivity of the lake was drifting around in the water column as plankton. Now all the productivity is being pulled down into these clams, which filter the water constantly and accumulate all of the food basically down in the bottom. So the food web of the lake has been really changed, and it's fundamentally different than it was in Lake Michigan 20, 25 years ago. And no one's exactly sure how that's affected, what the exact specifics of how that's affected the perch, but it correlates really well with the decline in perch. And so people think that probably is the reason, although exactly what did it is an area that people are looking at. And so right now the perch fishery in southern Lake Michigan is very poor, and the perch fishery in Green Bay is better, but nothing like it was, say 20 years or so ago. But we don't think that was related to, or at least not tightly related to the alewife or the salmon, because they tend to be more offshore in the colder water, and the perch tend to be closer to shore where the water is a little bit warmer, kind of harbor mouth, river mouth kind of areas, and lower Green Bay, which is a warmer area. And so most scientists think that the issue there is these mussels, the zebra mussel and the quagga mussels, and that's also led to these blooms of this algae called Cladophora, which fouls the beaches, and there's a whole bunch of other changes associated with it. But you're correct that the perch fishery is nothing like it used to be. And to be honest, we're struggling on what we might be able to do. I mean, the lake is just a different place than it was 20, 25 years ago.
John, are you able to give away any secrets into the highly competitive world of micro-angling? And how many minnow species are you up to, and what's the smallest you've ever caught?
Okay. These are people who know me, so they can ask these questions. Well, there is this bizarre subculture of angling, of which I have to say I'm a part, where it's called microfishing, where the idea is to catch these tiny minnows on a hook. And, it's just because you can. You're not going to use them for bait. You're not going to eat them or do anything. You just want to say, I caught a 2-inch northern red-bellied dace on a hook. And I got this idea a few years ago that I was going to try to catch 100 different species of Wisconsin fish on a hook. And of course, I catch bluegills and walleyes and muskies. I've caught all those things. But there's really only about 35 or so what we call game fish, and then another 20 or so non-game fish that get big enough that you can catch them kind of with conventional fishing gear. So if you want to get to 100, you have to target these 2-inch fish or less. And believe it or not, and this is where the web is an amazing place, there's a little subculture of people all around the world who are into this. And I guess I'm one of them. And you can actually buy they're from Japan, where this hobby is particularly popular. These specialized hooks, if you know hook sizes, the higher the number of the hook, the smaller it is. And so if you're using, say if you're fishing for a bass, you might use like a size 2 or a size 4, or maybe a size 6. Well, these would be like size 20, 28 or something like that. And so you can barely see them. And in fact, these hooks are specialized, and then they're hand bent to the right angle, and then they use a jeweler's file to make this tiny pin. And so, in fact, you can catch a tiny fish. And so the smallest fish I've caught on them is what's called a mosquito fish. And this fish is less than an inch in length. And right now, just to set the record straight, my goal is to hit 100, and right now I'm at 97.
Whoa.
So I have my goal this year is to catch 3 more of these, but now I'm getting to the point where I've caught all the common little fish, so now I have to really seek out these really, scarce and really specialized habitats. So these last 3 I'm sure are going to be tough, but I hope to get them this year. It's like a 1-pound test you get it, it's kind of snelled on because these things are too small to have an eye on the hook, so it's actually snelled on. It's about a 1-pound. Some people actually use sewing thread because, again, these things weigh a gram. They're not going to break your line.
Yeah.
And you can't fish blindly. I mean, you have to see them at your feet and dangle it there and then when one bites, you try to yank it out of the water. It's kind of a weird obsession. But I got 3 to go. 3 to go. Yes, a tiny piece of worm. I mean, and that's part of the skill is you have to get their mouths are so tiny. I mean, you almost need a magnifying glass to cut a piece of worm that small that would actually, and these really, really tiny hooks with a really, really small point. And even then, a lot of these fish are too small to get it in their mouth. They want to bite it, but they can't actually get it in their mouth. So, yes, it's catch and release. I don't have a trophy wall. But go online and look up microfishing, and you will see. I don't really take photos of it. I can put my own bizarre. But there are people who photograph every fish they catch, and they have like a little gallery of their 2-inch minnows of all different species, and they make trips. There's all these different species in other states, so they'll go to other states and go microfishing, to add to their life list. Yep. Yep.
So my question is related to fish farming. I'm interested in aquaponics, and I'm searching for a fish that kind of meets a trifecta of characteristics. First, it has a high breed rate. Second, it poops a lot. And third, it has a high demand for human consumption. I'm wondering if you might be able to recommend anything.
Aquaculture is not my specialty, but a lot of the species that work best, and a lot of this I know from my work in Mexico actually, are tilapia species, which of course you can get them in restaurants. They're popular to eat. They're omnivorous. They eat anything, but they eat a lot of plant material, so they're low on the food chain. It's not like salmon where you have to catch other fish to feed them. And yes, they die. Whenever you eat plant material, you poop a lot. And so a lot of the aquaponics systems that I'm aware of use tilapia. And now that's not a native species. It's also a tropical species. So there really isn't a worry that it would escape and become established here in Wisconsin. But that's been a huge issue in Mexico. Tilapia are native to Africa, and they've basically taken over areas in Mexico that are much more tropical where they can live. But here in Wisconsin, it obviously would have to be indoors and sort of a contained system. I know there's been some attempts to do it with yellow perch, which is, again, a native species and very highly valued species here for food. That's been more challenging. Tilapia, particularly the domesticated strains, you can maintain them in incredible densities, jammed into these tanks. And perch are much more sensitive than that. And so, but if you really are interested in aquaponics, I'd say some form of tilapia would be the way to go.
Another question? Yeah. Okay, I have a question about bluegills because you seem to follow them quite a bit. Mm-hmm. As regards to swimming, is there a way that you can coexist while they're breeding, or is there besides disturbing them? Is there a way that you can just don't go in the water at certain times?
Oh, you mean you as a person?
Yeah, swimming. Yeah.
Oh, swimming. Well, bluegills are the one thing about bluegills is that they do acclimate to humans pretty well. Now, of course, if there's bluegills spawning and you swim right over their nest or right next to them, you will chase the males away. And that does make the eggs or the larvae that might be in the nest vulnerable to other predators. But bluegills, by and large, I mean, particularly if they're used to people, they'll swim right up to you and look at you in the mask. So short of actually swimming right over their nest, you probably won't disturb them too much. And in fact, a lot of the stuff I was talking about, sneakers and satellites and that kind of stuff, was basically scientists sitting in the water and observing bluegills and watching what happened. And so they might be as far away from the nest as that post is, so 3-4 feet. And as long as you sit quietly, you can sit and watch this whole event from underwater or from the bank, particularly if you move slowly and you don't do anything threatening.
So you're not going to spook them away?
No, bluegills there are certainly some species that get spooked and are going to take a while to come back. But bluegills are pretty tolerant of people. They sort of know that a person with a mask isn't that much of a threat, and they're kind of curious. And the one thing about parental males on the nest, they will be incredibly aggressive, and they'll come up and kind of challenge you, to a certain extent. So I wouldn't worry too much about that. And in fact, I'd encourage you, if you got a nice lake where there's some bluegill beds, go put a snorkel on and just sit there and watch them. It'll be fascinating.
Also about bluegills and sneakers and satellites. Do we have any sense, do we know, what the proportion of males are there, are 10% of the males satellite males, or 5% of them, or sneakers, or do we have any sense of that?
That's actually that's a question we're interested in answering. It does vary from lake to lake, and the thought is if there's a lot of habitat, the thought is that sneakers and satellites become more common when the good habitat is limited, the good spawning habitat is limited, so that there's only room for a certain number of these big perennials, and all the other bluegills are kind of left out. There might be room for 50 nests, and there's 1,000 male bluegills in this lake. What are the other 950 males going to do? So part of it is habitat quality. So if you have a lot of good spawning habitat, lots of room for males to establish nests, there's always going to be a few, but they're going to be low. And then if you have, limited habitat, and then there's going to be more. But that's something we're actively looking at. One of the things we're interested in is that a lot of anglers know that big bluegills are very vulnerable when they're on the beds. And so they'll deliberately target these areas and catch and kill a lot of the biggest bluegills to eat. And so the issue is, if you're removing a lot of these big parental bluegills selectively, you're targeting them and going to these spots day after day and pulling them out, is that going to shift the whole population more towards these smaller fish? Because now all of a sudden it's a real disadvantage to be a big bluegill, because you're going to get caught and eaten. But if you're one of these little bluegills, even if you get caught, you just get thrown back. And so there's some thought that maybe where you have these heavily fished lakes where people are targeting and killing and eating a lot of these bigger parental males, that kind of shifts the whole population to these smaller, less desirable, from an angling point of view, sneaker and satellite males. So that's a research question we're interested in looking at. But the actual percentage varies depending on situations.
What method do you recommend if you're catching a fish and releasing it to make the fish more likely to survive?
Yeah, good question. First of all, the less if you can keep it in the water and never take it out of the water, that's always best. And ideally, if you have a net that has the right kind of mesh so that you can kind of cradle it while you're releasing the hook. Now, again, if you want to pop it out of the water quickly and take a picture or something, that's fine. But the less time it's out of the water, the less time you're actually handling it, with your hands and grabbing it, because you're going to knock some of the protective slime off. You might knock some scales off. Definitely bring some forceps or a hemostat or some kind of a thing to help you pull the hook out. That almost always is faster than digging in there with your finger. But yeah, if you get, people who are good at it, they bring the fish up to the side of the boat. They just reach in with, say, a hemostat, grab the hook, flip it, and the fish is gone and never even really touched. And again, if you want to take a picture, that isn't, 5 seconds out of the water isn't going to hurt. No, if the fish has actually swallowed the hook. So if it's in the lips or in the jaw somewhere where you can see it and you can get it out easily, yeah, you don't, that's what you should do. But if the fish has swallowed the hook and you can't just flip it right out, yeah, absolutely, cut the line. Most of the time, the hook will just eventually dissolve and the fish will be fine. But you don't want to try to rip it out of there, reach in there and try to get it. The fish will almost certainly be dead then if you do that. And a lot of times they don't die right away. You think, oh, it swam away, it's fine. But it's mortally wounded, it's bleeding internally, and it's going to die.
What is the trend for people buying fishing licenses? Is it going up, down, and how does that impact the DNR budget?
Well, the second part is a huge chunk of our budget. There are two main sources of money for DNR fisheries. There is the license sales themselves, and so the money from those licenses. And then there is also a federal tax on fishing gear. And part of that tax then gets distributed out to the states to use for fisheries management, fisheries protection. And so obviously the more people who fish, the more people buy fishing gear, that affects both license sales and that tax. Right now the trend in Wisconsin is flat. It bounces around a little, but it's flat. But we're definitely concerned because the average age of the typical license-buying angler is going up. And so there's some thought that, as the baby boomers age and retire and are no longer able to fish or to die, that we're going to reach a point where it's going to start declining. And there are some areas of the country where it is declining. Wisconsin and the upper Midwest is definitely a stronghold for fishing, and so as a proportion of the population, Wisconsin is always one of the top states for fishing. And even though we're like 25th in population, we're like 3rd in license sales or something like that, 3rd or 4th. And the states that beat us are like Florida, which has 5 times as many people. And Minnesota's similar, Michigan's similar. So we have a lot of anglers in this part of the world, and so for the moment it's been flat. That's one of the things we're actually looking at and spending a lot of time, how to recruit new anglers in, get people more interested, because basically license sales is the bulk. Either license sales or angling tackle sales are 95% of our funding. So.
I have a... Okay.
This is another one from the library. How long can a bass live without eating?
Without eating. Depends on the water temperature. So in the wintertime, a bass can probably live for months without eating. And they will lose weight. And I can remember, just as an aside, when I was a student, we had a big tank with very cold water. And it was just in the back, and no one was using it. And we realized later that there had been some bass that somebody had stuck in there, and no one knew it was in there, and so no one fed it for like 4 months. And it was sitting in this tank, and it was really emaciated. It was a hollow stomach, but it was alive after 4 months or 5 months at very cold temperatures. But in warmer temperatures, sort of summertime temperatures, again, it depends. A bigger bass can live longer because it has more reserves and everything. So a young bass is going to starve faster. But you're talking on the order of probably a few weeks. Again, it depends on exactly what the temperature is, what kind of shape it was in when it stopped eating and things like that. But they're not going to intentionally stop eating, and they will eat anything they can get. So bass and most species, particularly when they're hungry, will eat just about anything.
Susan? Okay, sorry. All right. We have a question about a white bass, evidently in Pelican Lake. And why are they so far north when there aren't any white bass in other lakes nearby? Did they arrive when the glaciers receded, and why aren't they found anywhere else this far north?
I don't know this for a fact, but I'm pretty certain that a white bass in Pelican Lake would be something that had been stocked. White bass is mainly a river species and kind of reaches the northern edge of its range in about central Wisconsin, so Pelican Lake is north of that. And so most likely somebody, maybe an angler, the DNR doesn't stock white bass, so most likely anglers at some point brought them in there, and it's interesting that if in fact there is a population there that they've persisted, but I don't believe they're native there. I think they were introduced at some point in the past.
Okay, one other question. Do you have any experience working on the early life history stages of fishes, like embryonic and or larval fish?
Not directly, and that's an area I'm kind of weak in. So is there a specific question?
There wasn't any more specific question, I think, yeah.
No,
Just-
myself I haven't, although there are people who that is their specialty, working on the very youngest parts, the egg stage, that newly hatched larvae when they're still living off their yolk sac and not feeding, and then the very, the first days and weeks of life. But I'm not an expert on that area.
Okay, we should probably wrap things up. Maybe one or two more questions?
I was just wondering if fish can change sexes. You know, if you're having these troubles with the bluegills, well, why not switch over? Or if there's some environmental impact that would cause, like you were saying, the embryo to create more females than males.
Well, that's actually, and I was talking to Jeff a little bit about this. Bluegills do not change sex. So if you say, oh, that's a female that became a male, no, it was always a male that just looked like a female and then changed its look. But there are certainly fish in the world that do change sex. A lot of the coral reef fishes do that, the wrasses in particular. So they may start out as a male and become a female or vice versa. And they look very different in the process. As far as I know, there are no fish in Wisconsin that, in fact, I'm sure of it, there are none that in Wisconsin or the upper Midwest that actually change sex. But again, in marine areas and some tropical areas, yes, there are. There are, what we've been finding, which is a little disturbing lately, is there are occasionally fish, and more commonly, that have both male and female characteristics. And this is thought to be because of a pollution factor, particularly pharmaceutical and hormonal wastes, and it basically causes an individual to develop both male and female reproductive organs simultaneously. Now, they can't fertilize themselves. There are fish that can do that. There are fish that have, again, in the world of fishes, basically everything is possible, and everything has been done, but not necessarily here in Wisconsin. So there are hermaphroditic fish that have both male and female organs and can fertilize themselves and lay eggs themselves, but not in Wisconsin. But there are then these fish, again, fish that don't normally do this, that are showing up with both male and female organs, and it's a concern, and it's thought to be a pollution type thing. But in Wisconsin, you're either male or female. Now, there is also some evidence that what kind of temperature you are raised at. When the egg is first laid, it isn't necessarily fixed whether it's going to be a male or a female. And so it may be the actual conditions in which the egg is reared that may determine whether it's a male or a female. But by the time it's hatched, that's figured out, and it won't change.
Okay. Thank you very much. Can we give a big round of applause for Dr. John Lyons? Thanks very much.